Hello. Let's solve number 85, maximal rectangle. Okay, I'm gonna read the problem. Given 2D binary matrix filled with zeros and ones. Find the largest rectangle containing only ones and return its area. Okay, let's see the example. There's an input two-dimensional array filled with 1 and zeros. You can easily find the largest rectangle area in yellow color. Okay, let's think about the algorithm to find this area. Okay, let's focus on input data. Do you remember the histogram problem, getting the largest rectangle? We can imagine the histogram using this two-dimensional array, especially for the area filled with 1. But as you can see, the number 0 is located in middle area, so it's difficult to draw a histogram with the whole array. So we can come up with an idea to draw a histogram for each rows. With the first row, we can draw a histogram, and we can do this for second row and the third row and the last row. And to get the largest histogram, we should accumulate each rows. Let's think about the third row. Histogram would be like this in accumulative manner, so we can get the largest rectangle in yellow area. In the first row, zeros are included, so in these columns, histogram's height should be 0. In this way, we can calculate all histograms for each rows. The sequence of getting histogram would be like this, and we can get the histogram like this for the third row. So we can get the largest rectangle using this histogram. So let's think about the algorithm to get the largest rectangle with this histogram. We are gonna use the stack operation. It's O(n) time complexity. Okay, I'm gonna explain step by step. Okay, index I moves from 0 to the index 4 toward the right direction. First, it does push operation for index 0 because the stack is empty, and then moves the I to the next. At this point, it does a pop operation for the first histogram because the current histogram is smaller than the previous histogram in the stack. When doing pop operation, we have to calculate the area. And then we push the second histogram in the stack. And then we also push the third histogram in the stack, because the third histogram is longer than the second histogram. So there is no pop operation at this stage. Okay, index I already moved to the third histogram, and then it goes to fourth histogram. At this point, we have to pop the third histogram, because the fourth histogram is smaller than the third histogram. At this point, we can calculate the area of the popped histogram, and then push the fourth histogram and move the index I to the 4, and also push the last histogram, because it's not smaller than the previous one. Okay, at this point, we should add the 0 histogram. Histogram's height is 0 to pop all the remaining histogram in the stack. And we should know that the remaining histogram in the stack are in ascending order. That's very important concept to calculate the largest area. Longer histograms are already popped, so let's calculate the remaining histograms one by one. Last histogram is popped and calculate the area. Width length is 1, and pop the first histogram. At this point, we could know that the width could be up to 3 because the remaining histogram in the stack located at index 1. So the distance from I could be used as width length to calculate the area. So the largest rectangle is calculated in this way. Of course, the last histogram is calculated with the width length is 4, but its height is just 1. So the area is smaller than the previous one, which is 6 from 3 by 2. It's a little bit complicated, but let's see the code for better understanding.